Three-dimensional problems often contrast space inside with coverage outside. Volume measures how much three-dimensional space lies inside an object. Volume uses cubic units because length, width, and height are multiplied. Surface area measures the total coverage of the object's outside faces. Surface area uses square units because each face is two-dimensional. Capacity describes how much a container can hold and is often reported in liters or gallons. Inside space, outside coverage, and container capacity require different units and sometimes different formulas. Name the measurement before touching the numbers. A rectangular prism's volume is the area of its base repeated through its height. Use length 8 centimeters, width 5 centimeters, and height 3 centimeters. Volume equals length times width times height. The base area is 8 times 5, or 40 square centimeters. 3 layers of 40 give 120. The volume is 120 cubic centimeters. The exponent 3 records 3 multiplied dimensions. A prism with dimensions near 10, 5, and 3 should hold around 150 cubic units. Volume counts three-dimensional space, not face coverage. Surface area adds every outside face of a solid. Use a rectangular prism with length 6, width 4, and height 3 meters. Surface area equals 2 length width plus 2 length height plus 2 width height. Paired face areas are 2 times 24, 2 times 18, and 2 times 12. Add 48, 36, and 24. The total surface area is 108 square meters. Square meters describe the 6 flat faces. A net of 6 rectangles would produce the same total. Do not multiply all 3 dimensions when the question asks for outside coverage. A cylinder's volume is its circular base area extended through its height. Let the radius be 3 inches and the height be 10 inches. Volume equals pi radius squared times height. The circular base area is 9 pi square inches. Multiply by height 10 to get 90 pi cubic inches. The approximate volume is 282.74 cubic inches. The radius is squared, while the height is multiplied once. A base near 28 square inches repeated 10 times should produce about 280 cubic inches. Build the formula as base area times height. A cube uses one edge length for every dimension and every face. Let the edge length be 4 feet. Volume equals side cubed. 4 cubed is 64 cubic feet. Surface area equals 6 side squared. 6 times 16 is 96 square feet. The numerical values differ because one measures inside space and the other measures outside faces. Cubic and square units keep the two answers from being confused. The same edge can feed different formulas for different targets. Capacity conversions connect cubic volume to practical liquid units. Suppose a container has volume 3,500 cubic centimeters. 1,000 cubic centimeters equals 1 liter. Multiply by 1 liter over 1,000 cubic centimeters. Cubic centimeters cancel, leaving liters. 3,500 divided by 1,000 is 3.5 liters. The conversion changes the label and numerical scale without changing capacity. A value above 3,000 cubic centimeters should be a little above 3 liters. Write the conversion factor so unwanted units cancel. Correct arithmetic can still produce an incorrect measurement label. A box measuring 5 by 4 by 3 centimeters is calculated as 60 square centimeters. The product 60 is correct, but square centimeters describes surface coverage. Multiplying 3 perpendicular dimensions produces volume. Keep the calculation 5 times 4 times 3. Track centimeters times centimeters times centimeters. The correct label is 60 cubic centimeters. The exponent on the unit records the dimension of the measurement. Ask whether the answer counts faces or fills interior space. Units are part of the answer, not decoration after it. Use 4 checks for volume, surface area, and capacity. Name inside space, outside coverage, or amount held. Choose the formula whose dimensions match that target. Track square, cubic, or capacity units through the work. Estimate from base area, layers, or benchmark conversions. Challenge. Find the volume of a cylinder with diameter 8 centimeters and height 6 centimeters. The radius is 4, so volume is pi times 4 squared times 6. The volume is 96p, approximately 301.59 cubic centimeters. Meaning chooses the measurement, structure chooses the formula, and units verify the result.